It's now time for me to invite to the stage Bogdan Mariesan, Senior Software Engineer at Accessa, for his presentation about high-performance message brokers out of the IoT world. It is always a pleasure for me to talk before former classmates. It makes me feel proud of my generation, because it was a great generation. So Bogdan's main interests are in back-end server-side technologies, especially working on big data system and REST APIs. Right after Bogdan's presentation, we will have Henry Tremblay with his presentation about Java 8, Lambdas, and functional programming. So don't leave the stage. We have more surprises for you.
Hi, everyone. Okay. It's always strange when I'm doing stand-up, so hope you don't mind making some jokes with this in my hand. My name is Bogdan Mariesan, as you already know, and I'm going to talk about this really fancy topic called high-performance message brokers out of the IoT world. Sounds fancy enough? No? Let's see. I have some live demo that I'm going to do later on. So for that, I have the code on GitHub, and so will be my slides. If you want to contact me after the meeting, if you need any extra information or anything, you can find me on Twitter or on LinkedIn. And now I say that we begin this talk. So, the agenda for today includes four topics, 3 questions: who, what, and where. You're going to find out in 1 minute what they're about. And as I promised you, the live demo. If you were expecting anything related to microservices, blockchain, and serverless, I'm sorry to disappoint you. This fancy title doesn't include them. But of course, we can talk about them at a coffee after this talk. So, have you ever heard of MQTT? Anyone in this room? Okay, there you go. Are you using any message brokers? RabbitMQ, ActiveMQ? Okay, there we go. So you'll be surprised that this is actually a messaging protocol. Okay, it's quite similar to AMQP, so to the other messaging brokers that you're probably using. And in the next couple of minutes, I'm gonna prove you why I consider that this messaging broker is really good for Java apps also, not only for IoT. Okay, MQTT, the who's. First of all, this protocol, messaging protocol, was designed in 1999 by Andy Stanford Clark from IBM. It was initially designed as a protocol, as a telemetry protocol in which satellites would pass information to oil rigs around the world. So that's why it was supposed to be really lightweight. You can imagine the traffic that needs to go through a satellite. It needs to be really lightweight, okay? And of course, battery efficient. The initial acronym was actually referencing that it was a telemetry protocol, but it was rebuilt in 2010. So actually from that point only, we only refer to it as MQTT, but the acronym stands for pretty much nothing. But the name was kept in honor to Andy Stanford Clark. Okay, it has 5 principles. It needs to be simple. This protocol needs to be simple to implement. So if you want to make a client for it, it's quite easy to do it. It needs to provide a quality of service for the data. Why it has to do this? Because unfortunately, but you will see why this is actually an advantage, it doesn't persist any of the messages in the broker, only during the actual routing of the message. Okay, it needs to be lightweight and bandwidth efficient. Actually, it's lighter than HTTP, and I'm going to tell you why. It's data agnostic. You could put in binary, JSON, XML, whatever you like. Protobuf, so it's really data agnostic. And it needs to have a continuous session awareness. I'm going to explain you this term in a couple of minutes, so bear with me for a couple of minutes. This is how an MQTT life cycle, or let's say a space would look like. You have the broker, and you will see here that we have a lot of brokers, even some that you're already using. And it can connect anything from things like sensors to mobile phones and all sorts of other devices, including industrial devices and all that. So if your app uses IoT devices, you can use this broker to have them communicate with each other. If you have some cloud applications, they need to communicate with the phones. Well, surprise, again, you can use this message broker to route messages to them. And maybe now you're still in the shadows, but when you see who exactly is using them, you'll actually realize that you've been using MQTT for the past years pretty much every single day. Okay, so as I previously said, this protocol is really lightweight. It's lighter than HTTP, okay? And for encryption, because we know that nowadays this is a really big problem, for encryption it uses TLS over TCP. Okay, you might have used similar protocols such as AMQP, STOMP, XMPP, whatever. And if you check the specs for MQTT, you would see that by the way in which the message is designed, or the protocol is designed, it's actually lighter than AMQP. Okay, so here's where you're using it. Facebook Messenger is using it for communication. If you know those chat messages that you have with your friends, your groups and all that, those are actually MQTT topics. WhatsApp is using the exact same technology for the same purpose. So yes, you've been using it even if you don't know. And if you're working with IoT, you've probably used either the Azure IoT Hub or the Amazon IoT Hub. And each of them have proprietary brokers implemented. Where to use it exactly? You will find out that you have a really large margin of areas in which you can use it, from anything to industrial stuff, to smart city, connected cars, cloud, even push notifications if you want that. So it's the kind of broker that you can use for anything, and you can do that because its main purpose is to route messages really fast. Okay, let's get ready to rumble. Yeah, actually I forgot something, Meme-Cat. Let's see what. I forgot to talk about the 5 principles in details. So what does quality of service mean in terms of MQTT? First, you have exactly 3 layers of quality of service, and this will guarantee how a message gets from the client to the broker. So just to understand each of them, you have an MQTT client that could be anything from a phone or a service. If you're with microservices, yes, that could be one of your services connecting to it. And in terms of QoS 0, it's fire and forget. The client fires a message to the broker redirects it to all the subscribers, but you have no guarantee if the message actually ends in the subscriber or not. This is really fast, you can imagine why. But of course, it's also really efficient. If you're talking about sensors or things like that, or logging or auditing, yes, you could use it for that. If you miss some events, who cares? In the end, you care about some errors, not all of them. Okay, quality of service 1. This is acknowledged delivery. This means that the client will try to push the message as many times as possible to the broker until it gets the guarantee that it's been sent at least once. Okay, so if you need on your subscriber and you can manage subsequent processing of the same event without influencing the state or anything, this is where you're going to use QoS 1. And if you have really sensitive data where you want to ensure that a command, for example, when you're talking to a satellite or a robot or some fancy equipment, if you want to make sure that it's going to get exactly once, so something like stop the nuclear reactor at Chernobyl, I don't know, then you're going to use quality of service 2. If you check a bit the amount of messages that's being communicated between the client and the broker, you can see why QoS is by far the fastest way of data transmission. And because of the handshake done with QoS 2, this is by far the slowest. Okay, regarding sessions, why do we need sessions? The way in which the broker is built, and one of the brokers that I'm going to show you has the capability of handling 1 million concurrent connections on a single node. It's the fact that each time a client subscribes to a topic, you have all sorts of handshakes that are being done, including authentication, and I will show you how that is done. And based on that, those things can be quite time and resource consuming. So if you have a sensor that's connecting every 2 or 3 weeks to report some sensitive data, you don't want to wait that much time for the connection. You want to be as fast as possible to gather the information from the sensor or the system, and then move on with it. This is using a thing that's called the client ID. This needs to be unique for each client. Otherwise, you will override your existing session. So this is, let's say, the way in which it ensures that you don't have client conflicts and all that. And in case you want to erase and redo authentication, all that, for that you have the clean session flag. These are really low-level stuff, so if you need to implement them, you will for sure hit into them. Okay, one of the really nice features in terms of MQTT is the fact that it has retained sessions or retained messages. What this means is that, let's say you want to have a message in the broker that will be accessible for all subscribers that will join in, let's say, 2 or 3 months. You can have, on each topic, you can have one such retained message, and all subscribers connecting or disconnecting will automatically receive this message. So this could be something like, imagine in a microservices world, you would say, hey, look, this is the authorization service. Yeah, I'm here. I'm just here for you. You can contact me. That's kind of the idea of it. And then it has another really nice feature, a specialized message, a retained message, which is called the last wheel. So in case any of our clients, be it a cloud service, an IoT device, wherever, disconnects ungracefully from the system, and I've listed here some of the things that might produce that last wheel message, the broker will know. So you will get a notification from the broker, look, I disconnected abruptly, I'm offline. This can be really useful if you need to know who is online at what time and if you need to react somehow if that happens. Okay, as you've seen probably on your phones, in terms of Facebook Messenger and WhatsApp, they're quite battery consuming. Why is that? It's because in order to keep the connection alive between the client and the broker, it's usually using this keep alive session, and it's sending this message. It's a really lightweight message. It's sending it based on your configuration. Facebook does it every second, so that's why Facebook Messenger is literally eating our battery, but based on the application, you can configure it how you like. And session client takeover, it's what I've discussed earlier. It's the fact that using the same client ID, you can overtake your previous sessions. Here are some of the brokers out there. HiveMQ, it's the thing with the, the B or whatever. EMQTT, this is the one that I'm going to present to you today. Mosquito, RabbitMQ, this is well known to Java people, and I sure hope it is. If not, you've probably heard of ActiveMQ, which is a, let's say, previous iteration of that. And then you have the Azure and Amazon IoT hubs. Okay, so why I'm going to talk about this broker? From what I've tested in the especially last year and more recently, this seems to be the most sturdy and fastest of all the MQTT message brokers. It was written in Erlang, so if any of you is a fan of functional programming, you're going to love this thing. The way in which it's built, it's really, really good for concurrent processes and for multi-threading. That's why it's capable of handling 1 million concurrent connections on a single node. How it's doing that? It's multiplexing the connections, so it's capable of switching the context really, really fast, and that's why you will find it really helpful. It has also an authentication layer over here, And besides the MQTT protocol, if you still favor some of the old school protocols, you can still use things like directly TCP if you like, or Stomp, WebSocket, or whatever. Another really cool feature is that it can bridge data to several other systems that you might be aware of or that you're using, like Kafka or Mongo or Postgres and all that. Also, based on these systems, it can also do authentication based on some of them. And I will show you why that's needed. Okay. So I think now it's time for a live coding session in which hopefully you will find love for this tool, or at least for this protocol. Let's go. Okay, I hope you can see it quite clearly. So this broker has a large number of plugins. Some of them are custom and they're built by some of them are built by MQTT. You have all sorts of authentication plugins such as JVT, Basic Out, and all sorts. Then you have this really fancy dashboard which you can use to monitor your cluster. And then if you fancy to build your own plugin for it, why not? You can, if you know functional programming and a little bit of Erlang, you can use this to bridge to whatever system to bridge data or a different message broker, even if it's not covered. In terms of clients, I can guarantee you that at least mobile phones and embedded devices have native clients using MQTT. And of course, since this is a Java stage, Java also has a really cool client that was built by Eclipse. It's named Paho. And how many of you are using Spring out of this room? Or Spring Boot? Okay, the fun part is that this tool is integrated with Spring integration. So you can, with some minimum configuration, and I will show you how, you can directly jump in and use this broker. All the resources, including a pre-configured instance of the broker, will be available on GitHub in a Docker container. And after this talk, I'm going to write down all the details, all the details about how you can start up a single node MQTT broker and how you can use the app to play around with it and do whatever you like. So what's really fancy about this dashboard, you'll have tracking of all the clients that are connected. If you remember the client ID, this is where I'm going to see it in a couple of seconds. You have active sessions. Again, this is related to, theoretically, each client should have one session. And you also have a history of all the topics. If you're used to message brokers, you know why this is important. If you have really large systems, the number and distribution of topics can increase by a lot, since at some point you will find out that you need to do some kind of sharding of the data. Otherwise, you won't manage to consume the data from a single topic. Okay, and you have something that states here subscriptions. What I forgot to tell you, or actually I avoided to tell because it's not part of the protocol, the default behavior for the system is a pub sub, so publish subscribes. You have a publisher and multiple subscribers receiving the same message at the same time. But in certain cases, you can configure something that's called a share subscription on a topic, meaning that it would work as a producer-consumer. So in certain cases, if you have a large amount of traffic on some specific topics, you can distribute that load evenly to multiple consumers. So this is a nice feature of the broker. In terms of plugins, as I've said, we have some authentication-related plugins, JVT, LDAP, Mongo, whatever. And then going down, we have some of the more technical things. You will find on GitHub a lot of projects that provide bridges or other plugins. And trust me, it's really easy to add a new plugin and to configure it. Of course, you can have listeners for it, okay? And the way in which I configured this broker by default, it can manage 1 million concurrent TCP connections and around 500,000 if they're encrypted. You can imagine why encryption and using a certificate usually slows things down a bit, but hey, at least we have security for it. And if you fancy some of the more, let's say, low-level things, and if you want to include it in your daily monitoring and all that, you have a really nice API that you can use. But now I'm going to go into the more interesting things. This dashboard also has an MQTT client included in it, and you can use it, and I will use it, to demonstrate some of the features that I've talked about. Okay, so first of all, I'm going to connect. I'm not going to do a clean session because I want to keep my session between retries. The client ID, let's say it's DevTalks client 1. Okay, keep alive, I don't care about it now. And we're going to connect to the broker. There you go, it's connected. Now, I've configured a message broker in the Java app, and I'm going to use the same one. Okay, let's take the topic, DevTalks demo. Okay. If you remember the quality of service, that's the way in which we guarantee that the client receives or not the message. You can set that individually for each client ID when they connect to a topic. What you need to be aware is that all subscribers need to know about this protocol. So if you're sending messages with QoS 0 and you're listening with QoS 2, you will receive nothing. So this is really important. I'm going to start with QoS 0, which is fire and forget. And you will see even in this demo, there is a slight chance that if you have a really high peak of messages in a real fast pace, it might lose some of the messages. So we're subscribing to the demo. It says that I'm subscribed. And if you don't believe me, there you go. The first client ID, it's unauthenticated because I didn't want to waste any time for that. You can even use your own authentication services with it. It has a default HTTP API that you can use for that. Okay. It has one open session where you can see that it's not with clean session. The topic, if it doesn't have the topic, it automatically creates it. Okay, and now let's play with some messages. So I'm going to say, hello, DevTalks, QoS 0, and I'm not going to send a retain message. Okay, the message is sent, and if I receive it, or if I resubscribe to the same channel, the message is gone. So this is the standard default behavior if you're not using retain messages. If it's consumed by a subscriber, that's it. The broker doesn't care. It doesn't do any kind of persistence. All the persistence of the messages happens on the client side, and you will see, and this is an advantage for the server because if you have, for example, sensors that went dark for like 6 months, you don't care what the temperature was 6 months ago. You care about the most recent readings. And clients have some ways in which they can persist the messages, either in memory, either in files. And in this case, the broker is capable of handling a large amount of connections because its main behavior and its main purpose is routing of connections, nothing else. Okay, let's see what happens if we do a retain message. Hello, DevTalks. Retained. Okay, sending it on the same topic. Okay, disconnecting. I'm actually going to disconnect the entire session. Okay, it was DevTalks demo. Subscribe, and there we go. It automatically received the retained message. So this is really helpful if you need to pass any kind of information, like if you're a sensor, you need the battery status, or you're a phone, you need to ask, or you have an app, for example, that's delivered on embedded devices or on phones. You could use this mechanism to let that phone know that actually you have, I don't know, an invalid or an older version of the API or whatever, and they can use that information to request an upgrade or so on and so forth. Let's see now what happens if we go in the Spring part, because I assume you're more interested into this part. I've created the Spring Boot app. It's Spring Boot 2.0, so it's latest, greatest, Spring 5, even if we're not going to use any of the features here. Okay, and I'm going to put this, I'm going to make it a little bit bigger, okay. I've built here two small apps, a producer and a consumer. The producer simply writes some messages, around 100 of them. We can play with the quality of service to see what it means for the broker, exactly the amount of messages received, how fast it takes to receive them. And then a subscriber, so I can simulate a behavior in which we have two parallel subscribers. Configuring it, it's done. Spring has a client factory for Paho, one of the MQTT libraries. And if you're familiar, at least at some level, with Spring integration, you can define inbound and outbound channels for receiving and sending messages. So if you're already using Spring integration for your project, you can easily switch to this broker. Okay, first of all, I'm gonna produce some messages. Okay, and there we go. The other subscriber received all my messages. Let's do another scenario. Now we're gonna start the other subscriber, the Spring-based subscriber. Okay. What's really nice about this part, as you see here, I've added a last will message stating that I'll be back again. So this one is subscribed to the topic. It defaults the message. So in case, for example, I clear the session and kill the client, automatically the I'll be back again message will be sent, stating that client ID with blah, blah, blah said that, look, I'm out, I'm disconnected, I'm offline. And to do that, I'm going to kill one of the processes. There you go. Eight, 3, 7, 5. And there you go. The broker automatically detected the message and it sent it to all the subscribers that one of them is down. You can use this behavior if you're really, for example, in a microservices architecture, when you have a large amount of services talking between them, this could be one of the ways in which to know that you need your circuit breaker to take over the work, because whatever service that was handling part of your sensitive data is down for now. So this is why it's different from a traditional messaging broker, is that it also has at least a level of state and understanding of what your clients are doing, when they're doing it, and how they're doing it. Okay, if you want to play with the app in more details, you have here a default configuration using basing TCP, so nothing fancy. You could configure it to use SSL and whatever, it's really simple. And you can play with it around on GitHub, and if you have any questions ongoing, I'll do my best to answer them, even after this talk. So, if you need to read, or if you want to read more about this topic, I would suggest that you read the following topics. So HiveMQ is one of the older brokers, but they have a really nice explanation for all the topics and all the wording that was part of this presentation. AMQTT is the broker that I've used for this presentation, and mqtt.org is the place where you can read about the specs. So if you're that low level and you want to implement your own MQTT client in Ruby or whatever, that's the place to go. So until the next time, thank you for attending this presentation.